Hello learners, today we are going to study organic chemistry, some basic principles and techniques. This is unit 12 in the second volume of NCERT textbook class 11th. In today's session, we will discuss the reasons behind the presence of a large number of carbon compounds, tetravalence of carbon atom, shapes of organic molecules, structural representation of organic compounds, three-dimensional structure of organic molecules and classification of organic compounds. The learning objectives of today's session are as follows. After attending this session, you would be able to understand reasons for tetravalence of carbon and shapes of organic molecules. Write structures of organic molecules in various ways. Classify the organic compounds. Viewers, do you know there are 118 elements in the periodic table? The compounds formed by carbon alone are double the number of compounds prepared by all other elements together. Nearly 9 million carbon compounds are known to us today. Moreover, scientists are daily synthesizing more and more carbon compounds. Naturally, a question comes to our mind. What is so special about carbon that a complete branch of chemistry is devoted to study its compounds? The reason is carbon has the unique property called catenation. Catenation means self-linkage ability, that is, carbon atoms have the tendency to link with one another through covalent bonds to form chains and rings, to form straight chain compounds as well as branch chain compounds. In addition, carbon atoms get linked by single, double or triple bonds. Carbon forms covalent bond with other elements also, like it forms bonds with hydrogen, oxygen, sulfur, phosphorus and halogens. Since carbon forms a huge number of compounds, so a separate branch of chemistry was developed known as organic chemistry to study carbon compounds only. So viewers, we start with organic chemistry. As we all know, organic compounds are essential for existence and maintenance of life on earth. Biomolecules like DNA, which is responsible for transmitting genetic information from one generation to the next generation. Proteins, which are essential for our growth. Carbohydrates that provide energy to us to carry out various activities. Minerals, vitamins, etc. all are constituted of carbon compounds. In fact, human being is a carbon compound that crawls. It is no wonder that until early 19th century, scientists believed that organic compounds can only be obtained from living organisms under the influence of some mysterious force known as vital force, present in living beings only. However, in 1828, Wohler, a German chemist, accidentally obtained an organic compound urea from an inorganic compound ammonium cyanate. This synthesis gave a death blow to vital force theory and clearly demonstrated that no mysterious force is required in the formation of organic compounds. Thereafter, millions of organic compounds have been synthesized. At present, 95% organic compounds are synthesized in the laboratory. Learners, you just look around yourself. You will find that material which we use daily, such as our clothing, fuels, polymers, dyes, medicines, etc., are made up of carbon compounds. Let us discuss the reason in detail for the formation of large number of organic compounds. We will talk about the tetravalence of carbon atom and shapes of organic compounds also. The carbon atom is central to all organic compounds. The knowledge of fundamental concepts of molecular structure helps in understanding and predicting the properties of carbon compounds. In chapter 4, that is chemical bonding and molecular structure, we have already studied formation of covalent bonds by carbon in terms of its electronic configuration and the hybridization of s and p orbitals. Learners, just recall the formation of shapes of molecules like methane, ethene and ethine using sp3, sp2 and sp hybrid orbitals by carbon atoms in the respective molecules. The bond length and bond strength depends on the type of hybrid orbital involved. Therefore, a single bond is longer than a double bond, which in turn is longer than a triple bond. However, single bond has minimum bond enthalpy, triple bond has a maximum bond enthalpy, and the bond enthalpy of double bond lies in between these two. Now, next topic that we are going to discuss is the structural representations of organic compounds, that is complete, condensed and bond line structural formulas of organic compounds. Learners, structures of organic compounds are represented in several ways, namely the Lewis structure or dot structure, dash structure, condensed structure and bond line structural formulas are some of the specific types. Let us talk about Lewis structure. In Lewis structure, a bond between two atoms is shown by the pairing of two electrons, shown as two dots. How to draw Lewis structures? That you have already studied in Unit 4, Chemical Bonding and Molecular Structure. The Lewis structures, however, can be simplified by representing the two electron covalent bond by a dash. Such structural representations are called complete or extended structural formulas. In complete structural formulas, we show all the covalent bonds. Learners, before moving further, one more point want to discuss with you, that is type of carbon atoms in organic molecules. The carbon atoms in an organic molecules may be classified into four types as primary, secondary, tertiary and quaternary carbon atom is attached to one other carbon atom. Secondary carbon atom is attached to two other carbon atoms. Tertiary carbon atom is attached with 3 and quaternary carbon atom is attached with 4 other carbon atoms. The extended or the complete structural formula can be shortened by omitting some or all of the dashes representing covalent bonds. This can further be reduced by indicating the number of identical groups attached to an atom by a subscript. The resulting expression of the compound is called a condensed formula. For further simplification, we use another way of representing the structures in which only lines are used. In this bond line structural representation of organic compounds, carbon and hydrogen atoms are not shown and the lines representing carbon-carbon bonds are drawn in a zigzag manner. Learners, as you can see here, this is the bond line representation of an organic molecule. So, here it is shown in a zigzag manner. And in this chain, if any terminal is there, any branch is there, that is shown by this line. And usually, we do not show the terminal ends unless and until some functional group is present at the end of the chain. So, that is all about the bond line formula. In the given slide, you can see all the 3 types of structured formula. Learners, using bond line formula of organic compounds, we can create interesting quotes and good wishes also. For example, you can see in this slide, using bond line formula, you can write Merry Christmas, Shubh Deepavali, Happy New Year and many other quotes. Such fun-filled activities make learning process interesting. So, learners, use your creative skills to write quotes and other interesting messages using bond line formula. So, moving on, next topic is 3-dimensional representation of organic molecules. Learners, as we know, organic molecules have 3-dimensional structure. Now, the question arises, how to represent them on a 2-dimensional plane, on a blackboard or on a whiteboard. For that, certain conventions are used. As you can see, I am holding a tetrahedral molecular model of methane molecule. So that now these two hydrogen bonds, they are in the plane of the paper and they are shown on a blackboard by drawing a simple line. While this one is in front of the observer. So this is shown by a solid line, while the last one is away from the observer. It is shown by a dashed line. Such type of representation is known as solid and dashed wedge formula. Using plasticine and sticks, you can practice making three-dimensional models of many other organic molecules. To understand the concept effectively, we are doing one simple activity. That is, take a chart paper and in this chart paper, draw a equilateral triangle like this. Hold the vertices of this triangle and bring them at the top of the meridian of the triangle. Now, learners, you can see we got a tetrahedral shape. Now, assume that carbon is present in the center of this tetrahedron. 4 points, at these 4 points, hydrogen atoms are present and they are bonded with carbon atoms via covalent bond. Learners, moving on. Now we discuss the classification of organic compounds. The need to classify organic compounds arises from the fact that a large number of organic compounds exist and their number is constantly increasing. Hence, it has become necessary to classify them on the basis of their structures. Let us first talk about acyclic compounds. They are called as aliphatic compounds also and consists of straight or branch chain compounds. For example, ethane, isobutane, acetaldehyde, acetic acid, etc. Next is cyclic compounds. These compounds are also known as closed chain or ring compounds. These compounds contain one or more closed chains or rings of atoms in their molecules, namely cyclopentane, benzene, anthracene and so on. Depending upon the constitution of the ring, cyclic compounds are further divided into two categories. These two categories are homocyclic compounds and heterocyclic compounds. First, we talk about homocyclic compounds. Homocyclic compounds contain rings which are made up of carbon atoms. These compounds are further divided into two subcategories like alicyclic compounds and aromatic compounds. Alicyclic compounds are closed compounds, consists of carbon atoms only. These compounds resemble aliphatic compounds in their properties. Their examples are cyclobutane, cyclopentene, cyclohexane, etc. Aromatic compounds are a special type of cyclic unsaturated compounds. Learners, do you know the name aromatic is derived from a Greek word aroma, meaning fragrant smell, sweet smell, pleasant smell. Since most of the compounds of this class discovered earlier had pleasant smell. However, the term aromatic has now lost its original significance because many aromatic compounds are now known to us possess unpleasant smell. The examples of aromatic compounds are numerous. A few of them are benzene, naphthalene and anthracene. Out of these many compounds, some are known as benzenoid aromatic compounds as they consist of one or more fused or isolated benzene rings like benzene molecule itself, phenol, aniline and naphthalene. Others are known as non-benzenoid compounds as they do not contain a benzene ring but are aromatic in nature. These compounds contain other highly unsaturated rings. Their examples are tropolone and cyclopropenyl cation. So, learners, after discussing homocyclic compounds, we will discuss heterocyclic compounds. What is the definition of heterocyclic compound? Heterocyclic compounds are the cyclic, closed compounds containing carbon and one or more heteroatoms like nitrogen, sulfur, halogens, phosphorus and so on. Among these compounds, again we have alicyclic, heterocyclic compounds as they contain heteroatoms and in their properties they resemble with aliphatic compounds. For example, tetrahydrofuran is an alicyclic heterocyclic compound. There are aromatic heterocyclic compounds also. They are closed compound containing heteroatom beside containing carbon atom, but in their properties they resemble with aromatic compounds. Their examples are furan. In furan, besides carbon, oxygen is present. In thiophene, besides carbon, sulfur is present. They all are cyclic compounds. Pyridine is another example. Learners, with this, session is over. I am sure you must have understood the basic concepts of organic chemistry. So now we summarize what we have learnt. Carbon is a versatile element. It forms basis for all living organisms and many of the things we use. The large variety of compounds formed by carbon because of its tetracovalent nature and due to its unique property of catenation. Carbon forms compounds using sp3, sp2 and sp hybridization. Formulas of organic compounds are represented in many ways. Three-dimensional representation of organic compounds can be depicted on paper by wedge and dash formula. Classification of organic compounds on the basis of their structure. Now let us try a few questions. First question is, what is the hybridization state of each carbon atom in the following compounds? These compounds are H2C, double bond, oxygen, CH3, CH2, Cn and C6H5, CH3. Next question is, write the condensed formula for each of the following compounds as it is shown on the screen. Now our next question is, write the bond line formula of the given organic compounds. Fourth question is, what are benzenoid compounds? Give 2 examples. Learners, with this, session gets over. I am sure you have enjoyed the topics we discussed and now we will meet in next episode. Till then, happy learning.